999 out of 1,000 times, if you have a free body diagram, suppose you draw a labeled free body diagram, and it is out of 5 marks, on your free body diagram, you should be expecting 5 forces. 4 marks, 4 forces, 3 marks, 3 forces. That is the trend. Okay, so let's take a look at this one. 2.2, draw a labeled free body diagram showing all the forces acting on block A while it accelerates to the left. So we haven't even read the question statement, but let me show you something. I can start drawing my free body diagram. What do I mean by that? I know fully well that the weight is gonna be there, so I don't need to read the question in order for me to put the weight on my free body diagram. I can put the weight and think about everything else after, because I know that the weight is going to be there. It's not up for discussion. The earth is going to be pulling the object toward itself. So now let's go ahead and take a look at our question statement so that we can identify all the other forces. Block A of mass 4.1 kgs is connected to block B of mass 2.3 kgs by a light inextensible string passing over a frictionless pulley. Block A is at rest on a rough horizontal table. So hearing that at rest on a table, normal force, that is the first thing. And we already know from the question that it is accelerating to the left. So if it is accelerating to the left, the frictional force must be to the right. So there we go, we have the frictional force. A and B are connected by a light inextensible string. So we have the tension force. There we go. And then a force F of magnitude 49 newtons is applied on block A. So there we go. Our force F of magnitude 49 newtons. So this is force applied. Let's take a look. 1, 2, 3, 4, 5. 5 marks, 5 forces. I think we are good to go. Let's go ahead and do 2.3. So 2.3, 2.3.1, we're supposed to calculate the magnitude of the kinetic frictional force acting on block A. So let's go ahead and do that. Quite an easy question. I would assume the frictional force is equals to, well, the kinetic frictional force is equals to the coefficient multiplied by the normal force. The coefficient between the surface of the table and block A is 0.35. So the coefficient is 0.35. All we need is the normal force, and we have answered our question. The normal force in this case is not going to be equals to mass multiplied by gravity because of this force applied. Okay, let me show you. The normal force plus the y component of the force applied. We can resolve the force applied into its components. They're going to be equals to the weight because the object is neither moving up or down. So by saying this, we're saying that the normal is the weight minus the y component of the force applied. So what is the weight? The weight is the mass, 4.1, multiplied by the gravity, which is 9.8, minus the y component of the force applied. The y component is going to be 49. So in a flat surface, cos is x and sine is y. So sine of 50 degrees. So let me get rid of this. I was just showing you how the normal force is coming about. So the frictional force is going to be equals to 0.35 multiplied by 4.1 multiplied by 9.8 minus 49 sine of 50. What do I get? 0.93. So 0.93 newtons. We're only interested in the magnitude, no need for direction. So there we go. That is 2.3.1. But what about 2.3.2? What does the question say? Acceleration of block A. We want to calculate the magnitude of the acceleration of block A by applying Newton's second law to each block separately. I guess people, they don't know that they're supposed to apply Newton's second law to each block separately. You know, the question even states apply Newton's second law to each block separately. I thought we all knew that, but it seems like we didn't. But anyway, stories. block A. Let's apply Newton's second law and see how it goes. So we're gonna have F net being equals to ma. Well, the force that is pulling the object minus all the forces that are opposing. That is how I usually say it. So the force that is pulling the object here is the y, not the y, but the x component of the force applied, Fax. So we have Fax minus all the forces that are opposing the motion of the object. So which forces are opposing the motion of the object? The forces pointing in the opposite direction. So in this case is the tension and the frictional force, and this is equals to ma. So Fax, that is going to be 49. We said that x is cos, so cos of 50 minus the tension. I don't think we have the tension. Minus the frictional force. The frictional force is 0.93. This is equals to ma, so 4.1 the mass, and the acceleration is also unknown. Okay, I guess we can solve these and yeah, move to object B. So let's do that. 49 cos of 50 minus 0.93. Am I doing that in the correct order? I think I am. So we get 30.5666 if we round off to 40 small places, minus the tension being equals to 4.18. So this is our equation 1. Let's take a look at B. So B, what's happening at B? We have the weight, obviously, and we have the tension force. Am I missing something? Obviously, we don't have the normal, it is hanging. We don't have any frictional force, it's not in contact with F law. So I think there we are. So are we moving at a constant acceleration? No, we are not. But the blocks are moving to the left, so B should be moving up. So the tension, well, let's start by saying F net is equals to ma first. And then the force that is pulling the object is the tension, and the weight is opposing, and this is equals to ma. So what is their tension? The tension is unknown. The weight is 2.3 multiplied by 9.8. This is equals to 2.3a. So tension, what is 2.3 multiplied by 9.8? That is 22.54. So minus 22.54 is equals to 2.3a. So let me, okay, I can make, what do I want to calculate? I want to calculate the acceleration. So I can make the tension the subject of the formula in this equation and then substitute into the first equation. Or I can just add the two equations. But in this case, I think it is easier if I make tension the subject of the formula. So T is going to be equals to 2.3a plus 22.54. Even if you add the two equations, it would still be fine. I think this is the first time I'm actually doing this. Usually I just add the two equations, but it doesn't really matter, right? The math is correct, we know that for sure. So if we substitute these T in equation 1, we get 30.5666 minus the tension, which is 2.3a plus 22.54. This is equals to 4.18, right? So 30.5666 minus 22.54. This is 8.0266, and it is equals to 4.1 plus 2.3. This is 6.4a. So a is equals to 8.0266 divided by 6.4, and this is equals to 1.25 meters per second squared. There we go. Tell me, which video do you want me to do next? I'm waiting.